I'll show you a quick demo here, but kind of a screenshot of what a GitHub workflow would look like. In this case, a build image. Of course, during that whole process, we're probably scanning, looking for vulnerabilities. Everyone's probably heard of software bill of materials or SBOMs, being able to generate that, and also leverage CodeSign with the Venafi PKS11 client can also sign those ones. So signing the attestations, and then of course signing and then deploying those attestations, SBOMs, other artifacts in the OCI registry for future lookup, for future validation, especially when it comes to runtime enforcement. Here on the policy enforcement side, right? So we talked a little bit about signing. Now that we have all of the artifacts signed and they're all compatible, standardized, it really makes it easy for the ecosystem. And for those of you that are familiar with admission controllers, it's a pretty popular way to be able to admit code and mutate in other areas. But here's a good example that I kind of borrowed from Kyverno, basically saying if we want to admit an application, we can write specific policy that says, okay, only these signed containers can be admitted. And there's a lot of them, right? So initially, Connoisseur and Kyverno integrated added support, OPA Gatekeeper, Kubeordinate is another popular approach. Of course, a lot of them support CodeSign just because of the adoption rate, and then even ones that continue to support older versions of Notary. And just quick shout out to the Venafi Nirmata solution. So once again, out of the box today, you can actually leverage the Venafi platform to sign container images and then push those secure images to the hardened registry, ideally, and then leverage the Nirmata Policy Manager and Kyverno to be able then to enforce that. Before we kind of jump into the demo here, so we're signing images, we're signing artifacts, SBOMs. We want to have some visibility into what's being deployed in these registries. So we do have an open source project called SigScan that can go in and literally comb the registry. We're going to look for signed images, signed artifacts, and then report that back, and then use that to leverage right against your policy and start seeing what's already been deployed, right? For those of you already familiar with Venafi and the CodeSign Protect platform, I'll be kind of walking you through what that looks like. Think of the day in the life of the InfoSec engineer, platform architect. So we have a number of, so this is for part of our data center portfolio. And you can see here I already have some projects enabled, ones that I've allocated for specific signing operations, right? So I have developers that are going to be going in and signing containers. A little bit about, so here's, let me just maybe zoom out. So we can see that I already have these CodeSign certificates that are going to be used, right, by these platform architects. And we can get some details on the certificate and the common name. So we're going to be using this one to sign. If I switch over to the Nirmata, so now we're thinking ahead, and from platform architect, I want to be able to now set up policy. So I already have one set up here called internal trust, and let's see here. So we already have some ones pre-configured. So I have one for, so in my environment, I want to be able to set up private trust with my kind of an internal Microsoft CA. So I have two policies right here that I've set up. And I'm going to go ahead and add a policy quickly called Venafi key. And so I'm going to call this one vSign. This one actually, I'm going to be using the certificate issued from the Zero Touch PKI that I have set up that I showed you earlier. All right, and then yeah, we're going to be certificate based. And oops. So here's an image based on the digest that I'm going to use. And then You can see the YAML that's being generated, right? So this is going to be deployed down to my local Kubernetes cluster. And of course, I already have, let's call this, give it a different name. See, hopefully it somehow didn't like that. Say 20. Okay, and let's try this again. Oops. 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 My fingers are. And let's make sure we do this. CTPKI. So we have the policy created, and we're going to now deploy down to my cluster. Okay, let's see here. So now we're going to switch over to the CLI, and let's try, and first of all, we're going to, so let's say some nefarious actor is going to go ahead and try and run an unsigned or maybe untrusted. So if you guys can see that, but hopefully. This one was generated with a different key that's not that I don't have the right policy for. So you can see up on the top level screen, I'm just getting all the logs. And then if I also then, I'm going to now attempt to run that image that I created the policy for. Now notice that we don't have any signatures quite yet. So that's why that's going to be complaining. All right. So now we're going to be running this workflow. So what this is going to be doing is we're going to be signing the this image. So within this workflow, it's literally just going to build the container. We're going to be signing with cosign. So if I just scroll back here, lots of good detail. You can kind of see here that we're, and actually in this environment, we're actually leveraging within Venafi CodeSign Protect. You can authenticate with of course the access tokens, but we can also exchange a JOT token for that access token. So that's what we're doing here against the OIDC provider within GitHub, and then we're signing. And so at this point, we can kind of see that should be. Oh, this is actually the different one. All right, so let's run this one actually. Too many actions here. This one is going to be now doing the cosign one. So while it's going, quickly show everyone here, once again, very similar, right? So we get the leveraging an existing Ubuntu image with the Venafi CodeSign client already installed with cosign, and we're of course authenticating, authorizing, and then we're signing, and so that should be done right there. And then we got a signature. And then finally, if we come back and we attempt to run, right? So now we have a successfully created pod. And if you take a look at the logs, once again, this is going against the kernel policy. So we can take a look at it. So it verified against the YAML policy. Just a quick takeaway from the demo, right? So once again, it's all about kind of stopping unauthorized code, especially in the realm of Kubernetes clusters. So of course, Venafi is ready, right? We have integration support for CodeSign and Notary v2. Definitely leverage Kyverno, some of the open source dynamic admission controllers. We have some good examples with Gatekeeper, with Kubewarden, and as you continue to evolve and mature your own container app kind of security, right? Combine this with utilities or ways to get visibility over these these signed images, and like I said, SigScan is a pretty cool tool for that. And then leverage once again resources on the Venafi open source site for GitHub, both the Notary v2 plugin and SigScan. Thank you.